Do you remember that Dr. House episode from the first season where a politician allegedly had AIDS and toxoplasmosis? And somehow, don't ask me why, Dr. House jumped into the conclusion that he had seizures when he was a kid, so nearly kills him. But finally, the politician said he took phenytoin. Well, today we are going to synthesize that drug. Phenytoin acts as an antiseizure agent by blocking sodium channels, and thus diminishing the rapid firing from neurons. It was synthesized by Heinrich Biltz in 1908, but found to be useful for seizures by Merritt and Putnam several years later. For this experiment, you will need 2.12 grams of Benzil, 1.01 grams of Urea, 100 milliliters of 96% ethanol, 3 grams of sodium hydroxide, and approximately 15 milliliters of 36% hydrochloric acid. The synthesis starts by adding the Benzil and the Urea in an adequate round bottom flask. Then add 50 milliliters of 96% ethanol. Drop a stir bar and start mixing. While stirring, add the 3 grams of sodium hydroxide dissolved in 10 milliliters of water. This paste is quickly formed. As a recommendation, add glycerin to a bath in order to get better heat transference. Turn on the heat and put the reflux condenser. The system looks something like this. After a while, the paste looks less thicker and eventually gets full liquid. A color change from brown to violet is spotted. Let's discuss the mechanism. The first step on the synthesis is the deprotonation of urea by sodium hydroxide with this resonance structure. Then, the deprotonated urea attacks the carbonyl of the benzyl, breaking the pi bond on this carbonyl. This intermediate forms and a proton transfer occurs. A double carbon-nitrogen bond is formed and OH- is removed, leading to this structure. The process is repeated in the other NH2 of the urea and attacks the other carbonyl of benzyl, leading to this structure. The K step in the synthesis occurs right here. The oxygen forms a double carbon-oxygen bond, and the phenyl ring rearranges into the carbon-nitrogen double bond, moving the pi electrons into the nitrogen atom. This way, phenytoin sodium is synthesized, and after acidic workup, we get our final phenytoin. After 40 minutes, the reaction got yellow again, and the reflux was kept for 2 hours. The reaction was cooled to room temperature, and this precipitate is allegedly diphenylacetylene diureide. Then, 30 milliliters of distilled water was added into the reaction mixture. Gravity filtration was used to remove this byproduct, and the flask was rinsed with 10 more milliliters of distilled water. In this filtrate, we have phenytoin sodium. So, in order to get free phenytoin, we have to add hydrochloric acid until the pH is between 1 or 2. As you can see, the crystals of water-insoluble phenytoin started appearing. Here is my attempt to get a closer look, but my camera is just bad. I set up the vacuum filtration apparatus with my brand new vacuum pistol. It's totally worth it. I really recommend to get one. As you can see, the filtrate is insanely purple. The beaker was rinsed with 10 more milliliters of water. Here you can see our crude phenytoin. Just for curiosity, I put the filtrate into a freezer for several hours. I got some bluish crystals and I separated them by gravity filtration. I got this nasty purple solid, which is allegedly 4,5-diphenyl 2-imidazolone. To finish the synthesis, the crude phenytoin was recrystallized with 25 milliliters of 96% ethanol. The heat was turned on and a little bit more of ethanol was added until we get a clear solution. Heat the ethanol until 20 to 25% of the volume has been evaporated. As you can see, the purple impurity was still present. The solution was allowed to cool, first to room temperature and then with an ice bath. This way we got white, tiny and beautiful crystals of phenytoin. We perform a final filtration and rinse the product with 10 more milliliters of cold, very cold ethanol. I turned on the hot plate and with a watch glass, I dried the phenytoin by moving it with a spatula during 5 minutes. I finally weighed my product using my $1 scale. At the end, I got 1.13 grams of phenytoin, which corresponds to a yield of 44%. And I also got these two products, which I mentioned before. I was very curious about the purple byproduct, and I found that it was a pH indicator. For confirming the molecule, I took the experimental melting point, which is not far from the theoretical, depending on the source. I also got IR spectrum, and as you can see, the signals present in this spectrum highly coincides with phenytoin structure. We have NH asymmetrical and symmetrical stretch, as well as CH stretch. We also get carbonyl asymmetrical and symmetrical stretch, which is characteristic from imides, for example, idantoins, and anhydrides. And the last signal we have is the monosubstitute benzene. As I said before, I run a second batch using these quantities, and I got a 50% yield. Thank you for watching and subscribe. I'm uploading new videos soon. Thank you.